All right, welcome everyone, and thanks for joining. This morning we've got a really good webinar for you. This is what we call AWS reInvent Unpacked, where it seems like forever ago we were at reInvent, but it was of course just about a month ago. But what we want to do is we want to go through some of the things that AWS and Aviatrix have done in terms of new integrations to expand our enterprise class networking solutions and our better together solutions. Today, we're going to focus on a couple of different areas: Outposts, Wavelength, the Gateway Load Balancer, serverless, some other things that we talked about at reInvent, but we want to give you a little bit more detail and go into those. We're happy to have Elena Broderson and Savi, okay, I'm going to try it, Savi here, Venkachalapathy with us today. They're going to be some of our speakers, and we also welcome Brad Hedlund, who is with AWS as well, and he'll be manning the Q&A panel for questions that you might have specifically on the AWS side. We also have folks from Aviatrix manning the Q&A panel for questions that might come up. So use the Q&A panel if you have questions during the presentations rather than the chat. That way we can answer your questions. And at the end, we'll open up and maybe bring up some of the questions that you've put out there during the session for everybody. You know, just in terms of the agenda today, what we're going to cover, I'll talk a little bit about the fundamentals of Aviatrix for anybody who is new to Aviatrix, just a few slides to give you an overview of what Aviatrix is. Then we'll drill down in some detail about AWS Outposts, and Elena will be presenting some of the key capabilities that AWS is providing there. And then Nicholas will be talking about Aviatrix and how we are adding advanced capabilities and tying those into Outposts. We'll also be talking about AWS Lambda and serverless functions and how folks can take advantage of Lambda capabilities with the Aviatrix infrastructure and get all of the benefits that the Aviatrix cloud network platform provides. And then we'll jump to Wavelength, where we'll look at how latency sensitive applications are being able to take advantage of bringing the connectivity all the way out into the carrier network so that you have the ability to support the new bandwidth capabilities that 5G, for instance, is delivering. And then finally, we'll touch on the new AWS Gateway Load Balancer and how we are supporting that construct as part of our FireNet solutions and bringing in next generation firewalls as well as doing security service chaining and leveraging the load balancer features that are now available. So now let's jump into the fundamentals of Aviatrix. Go through this quickly for any of you who are new to Aviatrix. Everything Aviatrix does is really based around a multi-cloud network architecture. And this is where we deliver advanced enterprise class visibility, full control of advanced networking and security capabilities, and then multi-cloud readiness or multi-cloud optionality. The foundation of this is the multi-cloud transit network. So this is how the application layers from any cloud are connecting into the multi-cloud transit, and the access layer is connecting into the multi-cloud transit. And this becomes the backbone within each one of the clouds, but also across and between clouds for enterprise companies who need this kind of requirement. Now, to deliver this is where the Aviatrix cloud network platform is delivered inside each one of the clouds to deliver advanced networking services, advanced security services, advanced operational visibility and troubleshooting capabilities, and then service insertion, where we bring in our partner products and help them connect into this multi-cloud infrastructure as well. Now, looking at the platform, just so you can give an idea of the pieces that go here, a lot of times people hear about this and they think of it as a SaaS or a managed service, but it's actually yours. It's software that you license from Aviatrix and put on your cloud instances. And some of the key pieces here, number one is the Aviatrix controller. So you can think of the controller as the brain of the operations. What it's doing is it's knowing everything about what's going on in your multi-cloud network infrastructure. It's talking to our Aviatrix gateways, as you see in number 2 here, that are delivering the advanced network and security capabilities, and the Aviatrix transit network. But it's also talking to the native cloud constructs via public APIs. So this is where we create a cloud network abstraction and have the ability to deliver our multi-cloud Terraform provider, so that you can actually create one infrastructure as code module that will work across multiple clouds, so that you start delivering a common repeatable architecture that can be used across all of your clouds. And then finally, we feed all of this great information that comes from the data plane, comes from the Aviatrix Transit, into number 4, which is Aviatrix Copilot, so that you have the ability to do network flow analysis and build multi-cloud dynamic topology maps and get that visibility that you're used to having on-prem, but now in the cloud environment. Now, if we look at how this sort of all comes together, you can see it's a very simple picture in terms of a hub and spoke architecture. But behind that hub and spoke architecture, there's actually a lot of capability in terms of building an equal cost, multi-path, high availability network that makes up that hub and spoke architecture. And all of our customers start in a single region of a single cloud. Most often this is AWS, and then expand to a region, so you can see that repeatable architecture. Also in AWS, in a single cloud, being able to do this and have a repeatable architecture. Then of course that can extend as you need to extend that network into multiple clouds. You have the same exact architecture, the same hub and spoke architecture, the same capabilities, and you'll have the same visibility and control that you have going forward. Now, we can add additional features. For example, high performance encryption, where the entire network is encrypted by default end to end. We can deliver up to 90 gig of high performance IPsec encryption inside the cloud, and between, say, on your direct connect from on-premise into the cloud, we can give you full wire speed capability up to, I think, 25 gig going into the cloud. We also support multi-cloud network segmentation. So you may be familiar with security domains and the ability to do connection policies on what people have access to. We have the ability to then extend with our transit network, extend that multi-cloud. So you can see, for instance, blue dots would be able to talk to other blue dots, green dots would talk to green dots, and you can have even shared environments like a purple dot here. But doing that with a consistent connection policy across your entire network environment. We also, as I mentioned, do service insertion and chaining. This is where we would bring in our partner products like next generation firewalls or an F5 load balancer that might be able to do SSL decryption and then service chain that traffic. And we route all the traffic automatically for inspection through these services. Then as I mentioned, we provide all this great data into the visualization platform. And this is something I encourage you to, connect with us and get a demo of, because once you see this, you'll really understand the value of it. And then, of course, once you have this transit, many of our customers want to be able to connect branch offices and remote users, take advantage of all of those capabilities like the network segmentation, and be able to do secure ingress and egress so that you can comply with, for instance, regulatory or corporate policies for restricting access to the internet. And then, of course, we support the native cloud construct. So this is the case where, for instance, we can support an AWS Transit Gateway, or we can support the AWS Route 53 DNS services, or CloudWatch, or other native services that are offered by AWS. We can connect in those, and we can support the native APIs to actually take advantage of those capabilities. So this is actually participating with the native constructs as opposed to replacing the native constructs, for example. So this is essentially what we do. And in the end, we're bringing the simplicity and the agility that everybody expects from cloud, but we're adding on top of that the enterprise visibility and control and operations and security that enterprise class customers really require as they build out their cloud networks. So that's my introduction. I'm going to go ahead and we'll move on to Elena, and welcome, Elena. Take it away.
Great. Thank you, Rod. I appreciate that. Okay, team. Well, thanks for joining this morning. As Rod mentioned, my name is Elena Broderson. I'm a member of the partner network AWS and focused on the technical validation and go-to-market execution for ISV validated solution offerings on Outposts. So on this slide, what I'll start with is that we're seeing an evolution where customers have a continuum of applications that are either easier or harder to move to the cloud. In this continuum, workloads on the left-hand side are easy to migrate to the cloud and often include everything from back office applications, SaaS applications delivered to mobile devices. On the right-hand side, what you'll see is that we're addressing workloads that are harder to migrate, whether that's because of low latency or local data processing needs for workloads that may run on factory floors, for automated operations in manufacturing, real-time medical imaging, or content and media streaming. And in the middle, we have workloads that could either use cloud or on-prem solutions, depending on what's available in the region. This type of situation usually involves data that needs to remain in a particular country, state, or municipality for regulatory, contractual, or information security reasons. Go ahead and advance the slide, please. Awesome, thank you. At AWS, when we think about the app continuum, we also need an infrastructure and services continuum to help our customers run applications wherever they need it. Starting off with the AWS regions that serve most customer use cases, and then extending out to the farthest parts of the edge with IoT and disconnected environments. We're also building out services in the middle tier where customers need AWS infrastructure and services on premises, in large metro centers near end users, and at the edge of 5G networks to reach mobile devices. When we look across this continuum, AWS regions serve the needs of most customers' use cases. For middle tier, Outpost provides AWS infrastructure and service and customers on-premises environments, and it's really the building block for AWS local zones that bring AWS services closer to end users in large metro centers, and then AWS Wavelength that delivers AWS services to the edge of 5G networks. For workloads that need to run in remote locations where there's a lack of consistent network connectivity or no on-premise availability, there's AWS IoT Greengrass, and then of course we have the Snow family of devices for rugged environments. Next slide, please. Okay, so there are three main reasons that dictate why applications must remain on premises. First, latency-sensitive applications. For some of our customers' businesses or business-critical applications that are sensitive to latency and variability in latency, you need applications to run on premises to support either equipment and processes that are sensitive to compute latency in order to ensure smooth and predictable operations and to provide superior experience to end users and to maintain, of course, a competitive advantage. Our customers have adopted the Amazon cloud for centralized operations, but find often that they need to run compute, graphics, or storage-intensive workloads on premises to execute interactive workloads, such as AR, VR, design, and visualization. These may be workloads that span a variety of host and storage systems. Examples include running on factory floors for automated operations and manufacturing, real-time patient diagnosis or medical imaging, and content and media streaming. Second, we have local data processing and data integrity needs. There's been an exponential increase in the data that is being generated by users and devices, and data integrity is a key concern in locations that are bandwidth constrained. You have data-intensive workloads that collect and process hundreds of terabytes of data each and every day. Transmission of the large volume of data to the cloud is wasteful and expensive for some customers. And transmitting message or data over long-distance internet connections can also lead to packet loss, resulting in data integrity problems. It would be good to process the data locally to respond to events in real time and to have better control on analyzing, backing up, and restoring the data. At the same time, customers would like to leverage cloud services such as AI frameworks or analytics they do in the cloud for data visualization and insights. They'd like to use services such as RDS to store data locally and seamlessly transfer it to the cloud later. Applications that process this data to drive better data visualization or business insights need to run on premises close to the data sources or end devices. Third, we have applications with data residency requirements. You may operate in geographical jurisdictions where regulations dictate that data and infrastructure reside in specific countries. Alternatively, you may do business with businesses and public sector entities where contracts specify where applications are deployed. Lastly, your enterprise may be in the process of migrating to the cloud that aren't there as of yet, and you're not ready to move to AWS regions for InfoSec or other reasons. If we can move to the next slide, thank you. There are also additional challenges that occurred as part of our discovery with customers. IT challenges, procurement and provisioning cycles are complex and long, often 6 months to get servers deployed. There are multiple vendors to procure, install, and maintain on-premises infrastructure. How we can bring efficiency and consolidation in procurement, installation, and maintenance, including consolidation of suppliers, is important. Then the significant overhead to patch and upgrade on-premises infrastructure, managing against a complex compatibility matrix across various hardware and software components. How to eliminate time spent on infrastructure, lifecycle management, and elimination of maintenance downtime is important. And of course, how to accelerate the delivery of IT services to improve business continuity is a priority. Then we have developer challenges. For these developers, how to use different APIs and tools to build apps for the cloud and on-premises environments, and then the need to re-architect them to work in other environments is an issue. How to build applications once, run on-premises or in the cloud using the same APIs and tools, using a wide range of popular services and APIs that they're used to in the cloud for the applications that run on-premises would be a huge advantage. All of these lead to business challenges. Inefficiency in IT results in poor ROI for technology investments and slower business growth. As a result, on-premises environments lag behind cloud in the pace of innovation. And how to leverage new technology innovations for better and faster deployment of services and deeper insights. So how to enable innovation in your on-premises environments using the services you run in the AWS regions. So if we should summarize, we know that our customers want the same reliable, secure, high-performance infrastructure. They want that same operational consistency, and they want the same access to services, APIs, tools for automation, deployment pipelines, and security controls that they can provide so that they can deliver on a high pace of innovation as they would in the cloud. If you go to the next slide, what you'll see here is that we're introducing Outposts. And so we heard all of this feedback from our customers. And at reInvent 2019, we launched AWS Outposts. If you move to the next slide, I'm just going to briefly talk you through what Outposts is for those of you that are unfamiliar. Outposts enables our customers to develop once and deploy in the AWS cloud or on premises without having to rewrite their applications. With Outposts, our customers have the same hardware and software infrastructure and a consistent set of services and tools across their AWS cloud and on-premises environments to build and run modern cloud-native applications anywhere. AWS Outposts is a fully managed and supported service by AWS. AWS automatically manages and updates the Outposts as part of its ongoing operations in the public region. So our customers don't have to worry about updating or patching infrastructure. Outposts allows our customers to choose the native variant of Outposts, and sometime in 2021, we'll likely be announcing a VMware variant for Outposts. And on AWS, the AWS Outpost variant, the management plane sits locally in the cloud, and then the APIs, management console, automation, governance policies, and security controls for all their applications across the cloud and on-premises locations. Use the same AWS console to view and manage resources, whether those resources and services are in the cloud or on-premises. And you can use the same CLI and SDKs as you do today to run and deploy applications using the API endpoints that you use today as well to run applications in the cloud. In September, we launched Outpost Service Ready as our single mechanism for promoting Outpost validated solution offerings externally in the marketplace. Approved partners like Aviatrix are asked to meet a high bar for technical validation and proven integration with Outposts as part of the application process. So in turn, that means that AWS has such a high degree of confidence in our partners and Aviatrix specifically, and their ability to contribute to really meaningful Outposts and AWS customer outcomes at scale. So to that end, what I'd like to do is turn the conversation back over to the team at Aviatrix to just talk us through their specific use case for Outposts.
Thank you, Elena. This is great. We appreciate it. Hey guys, this is here Nicolas from Aviatrix, and now we're going to deep dive into how Aviatrix integrates with AWS Outposts. Really, the bottom line is that the Aviatrix platform runs on Outposts. This brings the repeatable multi-cloud network architecture to Outposts with the common control plane that supports the native cloud APIs and advanced networking and security capabilities that we need to create a common data plane with the visibility and control that we're looking for when building an enterprise class cloud network. So the Aviatrix controller typically remains in the public region. It deploys, it manages and monitors Aviatrix gateways that physically reside in Outposts. An Aviatrix active mesh transit network is built using those gateways in Outposts. And so this allows Aviatrix to provide networking and security in the following use cases. First is inside a given Outpost rack. The second is across different Outpost racks. The third is Outpost to a non-Outpost on-prem data center. And the last one is Outpost to the public AWS regions. So let's explore those use cases in more details now. So the first one is intra-Outposts, right? But we typically are going to deploy more than one VPC inside this Outpost environment. So when using Aviatrix, the first advantage that you will have is the network automation. Because using the Aviatrix controller, an Aviatrix active mesh network is going to be deployed in Outposts. More specifically, the controller is deploying a redundant pair of Aviatrix spoke gateways in the spoke VPCs. This is where the workloads reside. The controller is also deploying a redundant pair of Aviatrix transit gateways in the transit VPC. Then the controller is building redundant encrypted active mesh peerings between the spoke gateways and the transit gateways. So as a result, the Aviatrix control plane is automatically learning and propagating the routes to the spoke gateways. In the end, this enables encrypted high-speed connectivity between the workloads over here in the Outpost Spoke 1 VPC and the workloads in the Outpost Spoke 2 VPC. Now, traffic flows are optimal with Aviatrix gateways because the traffic is always staying local to Outposts. When using the AWS TGW for the inter-VPC architecture in Outposts, it turns out the TGW service is still in the public region today. However, you can use VPC peering between two VPCs and outposts, and the flows are going to stay local. However, VPC peering can become operationally complex and difficult to scale. That's why a hub and spoke transit architecture is usually preferred. Aviatrix gateways can provide this architecture for the customers on outposts while keeping the inter-VPC traffic local to outposts. At the same time, the network management is simplified for the outpost workloads. There is no need to assign customer-owned IP to the instances, and no changes are required in the VPC route table for customer-owned IP routing. So that also leads to higher scalability because the VPC route table size essentially stays very minimal. Now, for security, Aviatrix, as Rod explained, is bringing the concept of a segmentation domain, which is an enforced network of VPC members. VPCs in the segmentation domain can communicate with each other, and VPCs not in the segmentation domain cannot communicate with each other. If needed, the communication can be allowed with policies, and it makes it very easy to control your security. Those domains are supported in Outposts, and they can extend to the public region and to on-prem. So really, in the end, it's completely consistent with how you design and operate your network with Aviatrix in the public cloud. The second use case is communication between Outpost and the on-prem data center. Because that's a very important use case. It's, of course, very common, as Alan explained, to have on-prem resources not yet hosted on Outpost, and the need to send or receive data to Outpost workloads. Normally, you would need to assign a second IP to your Outpost instances when they need to talk to non-Outpost resources in the on-prem data center. Aviatrix can help here because the Aviatrix transit gateways can act as NAT gateways. Essentially, they perform a many-to-one NAT operation from Outpost to on-prem, which means that instances can keep their unique private IPs. Only the Aviatrix transit gateways have a customer-owned IP for on-prem communication. They NAT the traffic back and forth, so it scales very nicely. It's also very efficient operationally because there's nothing special to be done on the Outpost workloads, and so the applications team have nothing specific to do. The second advantage is for the routing, because of course Outpost VPCs can be dynamic. The Aviatrix control plane automatically learns those VPCs and announces them to on-prem using BGP. The same happens in the other direction. The Aviatrix controller is propagating the on-prem routes to spoke VPCs. What's great is the segmentation domains that we talked about, they also apply to on-prem. We can also secure using exactly the same concept, the communication across Outpost and the on-prem data center. The third use case is Outpost to the public AWS region. Aviatrix can enable this connectivity because using the Aviatrix controller, the same Aviatrix network architecture can be deployed in any public AWS region. And so very simply, an Aviatrix encrypted transit peering is going to be established between Aviatrix transit gateways across Outpost and the same gateways in the public region. So the Aviatrix control plane is going to propagate the VPC siders across the Outpost racks and the region, therefore enabling end-to-end connectivity. The data plane traffic can go over a direct connect or the public internet. So in the end, you get this full consistency in architecture, operations, control plane, and data plane. Which brings us to the last use case. It's the fact that Aviatrix is providing this deep visibility and troubleshooting into the Outpost network. This is mainly done with the Copilot platform, which provides a global operational view of your cloud network. Copilot does a dynamic topology mapping to maintain an accurate topology of the global cloud networks, which of course now includes Outposts. There's also Flow IQ, which analyzes the global network flows and displays global heat maps and time series trend charts, so you can easily pinpoint and troubleshoot the traffic anomalies. And finally, Copilot has this application level intelligence that we call App IQ, which displays just the relevant topology when troubleshooting connectivity between two instances across VPCs. So that would apply equally well for VPCs that are in Outposts. You get the performance monitoring data, the flow data, and the security groups that are relevant to the source and destination instances, so you can easily pinpoint the issue and take whatever action necessary based on your analysis. So this could be for traffic inside Outposts or also between Outposts and anything outside. All right, so this is it for the deep dive in Outposts. Now we're going to move to the second topic of the day, which is Lambda, serverless, and how Aviatrix ties into that. So I'm going to start with the fundamentals, like doing a level set on Lambda, and then we'll move into Aviatrix. So essentially, Lambda is a service where AWS is running the server and is dynamically managing the allocation of the machine resources. As a result, is really efficient and very simple, because as a user, all you need to provide is your code, which could be in all your favorite programming language. You define what triggers your code. It could be an API call, or it could be a database event, etc. And you don't need to manage the VM. You don't need to manage the storage. You don't need to manage any of that. What's also great is it's cost effective. For example, one number you can see over here is showing that the pricing is based on the actual quantity of resources that are consumed by your application, rather than on pre-purchased units of capacity. So one use case example of Lambda would be a company that's developing a weather app for example, for mobile devices. And so the front-end code could be hosted on S3, and when a user clicks to get the local weather information, that's going to trigger an API call to Amazon API Gateway, which then is going to trigger Lambda. So it's going to on-demand trigger your code in Lambda, which is going to grab the information from typically DynamoDB and return it back to the user. Now, our webinar is about reInvent 2020. So there was quite a few nice announcements on Lambda. The first one is, as you know, with Lambda, you are charged with the time only for the time that your code executes. And this used to be rounded up to the nearest 100 milliseconds. But since reInvent 2020, the duration is now rounded up to the nearest millisecond with no minimum execution time. So with that new pricing, essentially it means you're going to pay less most of the time. But it's going to be much more noticeable when you have functions whose execution time is much lower than 100 milliseconds, which can be very typical for low latency APIs. The second one is that you can now package and deploy Lambda functions as container images. And so this makes it easy to build Lambda-based applications using all your familiar container tooling, workflows, and dependencies. And the last one is CloudWatch Lambda Insights, which provide clearer and simpler operational visibility of your functions by automatically collating and summarizing Lambda performance metrics, errors, and logs in pre-built dashboards. And so you get visibility on your function costs, on your duration and the memory usage, etc. Okay, now, how does Aviatrix work with Lambda? Well, it's really great because all the architecture that Rod explained at the beginning, and then I explained with Outposts, they work seamlessly. They're completely repeatable with Lambda. Really, the way it would work is using a very simple design. When you have a Lambda function, you can associate this Lambda function to a VPC. And so you would do that, and in that VPC, you will deploy an Aviatrix Spoke Gateway. It's the same Spoke Gateway as you would use for any other regular VPC. Now, the Spoke Gateway is going to get connected to the Aviatrix network. And as a result, your serverless code running in Lambda is going to naturally get access to the entire Aviatrix cloud network. So that means workloads in the same region, as you can see over here. It means workloads in other regions, in other clouds, or on-prem with the entirety of the Aviatrix feature set that we explained so far. So if we look at a broader architecture, we still have our Lambda function on the top right-hand side that goes to our Lambda VPC. But you see, one thing you could easily do is use the firewall network feature that we explained at the beginning of the webinar, because you could this way easily secure your Lambda code as the packets are flowing and reaching to another VPC or to the internet or to on-prem. In the same way, the same Aviatrix transit gateways that you deploy are going to be your entry points for your on-prem communication using BGP and IPsec VPN that could be over the public internet or over Direct Connect. Now, the same way we were explaining how you connect to on-prem or to another region also just applies exactly the same way. So you see, if our Lambda function resides in US West 2, but needs to access workloads maybe in US East 1 of AWS, the same Aviatrix architecture is going to be deployed, and only one-click encrypted transit peering is going to be established between your transit gateways in US West 2 and the equivalent gateways in US East 1. Okay, this is it for Lambda. So now I'm going to pass it over to Sad and Savi to start on Wavelength. So I'm going to stop sharing, and Sad, I'll let you start sharing your screen.
Sounds good. Thanks, Nicholas. All right, Savi.
Thank you, Sad. Thank you, Nicholas. Hi, everyone. My name is Savi Venkatachalapati, and I'm the Global Go-to-Market Specialist for AWS Wavelength. So Alena briefly touched on how AWS brings cloud continuum and bringing AWS cloud to where customers need it. And AWS Wavelength is AWS cloud at the mobile edge. So AWS Wavelength is essentially AWS infrastructure. So our own compute, storage, and network infrastructure that we embed in our mobile carrier partners' mobile network. Since it's AWS cloud, the same single pane of management, easy to console and dashboard that you're used to for managing your resources in the region, you can continue to use that for managing resources in the wavelength zones as well. AWS Wavelength brings application portability, which means you can develop your applications once and you can deploy them across wavelength zones of any of our CSP partners or mobile carrier partners worldwide. Next slide, please. Thank you. So AWS Wavelength, it provides ultra low latency to applications. So let's take a mobile application, for example. So if you have a UE or a edge device that's connecting to an application endpoint hosted in the region, the typical traffic flow would be from the mobile device or the UE over the mobile network through the packet processing core and then the carrier backbone, then the internet before hitting the application endpoint in the region. What that means is for this application, you could see latencies of tens of milliseconds to a couple of hundreds of milliseconds. However, for edge applications that require really ultra low latencies and that require the processing to be done at the edge of the mobile network, then you can run those applications in the wavelength zone. So let's consider that example. You have your application endpoint in the wavelength zone, and you have your UE device or the edge device connecting over the mobile network. Now the traffic flow would go over the mobile network through the RAN packet processing core and then hit the endpoint in the wavelength zone. So it doesn't have to traverse the internet. So what this means is now you can service your applications from the wavelength zone with ultra low latency. You can deploy those latency sensitive components. So take, for example, if you want an AI ML based model. So you can build and fine tune and train your model and fine tune and build it in the region. However, you can run the inference at the edge, in which case you are still able to connect to the services in the region over the high bandwidth service link that connects the wavelength zone to the parent region. So by hosting applications at the edge of the mobile network in the wavelength zone, you can deliver low latency, reduced latency to your mobile applications. Okay. AWS Wavelength, it's built on familiar services. So today we support Amazon EC2, T3 for generic compute workloads, R5 for memory intense workloads. And if you're looking to run video processing, video recognition, or inference at the edge, then we have G4, the GPU instance type. We have extended VPC to the wavelength zone. We also support Amazon EBS. And if you're looking to manage your containers, whether it is Docker or Kubernetes, then we support both Amazon ECS and Amazon EKS for managing your containers in the wavelength zone. Not only that, the application toolkits, whether it is in Amazon CloudWatch or the AWS CloudTrail or AWS CloudFormation, where you can create templates for your applications, you can continue to use them at the wavelength zone as well. So these are some of the core services that we support locally at the wavelength zone. However, you can still seamlessly access the rest of the 200 plus services in the region, whether it's SageMaker or IoT Core in the region over the service link that connects the wavelength zone to the parent region. Moving on. So for the AWS Wavelength, we have a growing list of CSP partners, Verizon here in the US, Vodafone in EMEA, KDDI and SK Telecom in Japan and South Korea, respectively in APJ. So the wavelength zones are generally available. Here in the US, we have 10 wavelength zones with Verizon. We have a wavelength zone in South Korea with SK Telecom and one in Japan with KDDI. Moving on, I want to give a quick overview of some of the use cases that you can enable with the low latency cloud AWS Wavelength Zone and 5G network. As one of our healthcare customer demonstrated, using AI ML-based inference at the edge for processing and analyzing video, they are able to assist medical care, healthcare professionals in real-time diagnosis. So in the healthcare, whether it is for image processing, video recognition, for real-time diagnosis use cases, you can run those applications in the wavelength zones. On the other hand, for example, take smart factories, which are going through innovations under the Industry 4.0 umbrella. We were able to showcase with one of the global SI partners how you can automate the quality control inspection in a smart factory by using the 5G cameras that are overlooking the assembly line. You can send the video feed in real time over the 5G network to the AWS Wavelength Zone, where you can run AI ML-based inference, run video recognition, and determine whether the manufactured part met the quality standards or not. Similarly, with our M&E customers, media and entertainment customers, we have demonstrated streaming high fidelity 4K and 8K video from the wavelength zone over 5G. So now you can create immersive in-venue experiences for fans at sports and events. Similarly, AR, VR streaming, mobile game streaming, or even the connected vehicles, being able to send secure communication messages in real time, being able to analyze the board safety messages that are sent from the sensors, LiDARs on the vehicle to the wavelength zone over the 5G network and sending notifications and alerts back to the connected vehicles. So in essence, these are some of the use cases that we can enable with AWS Wavelength. So start exploring your mobile edge use cases at Wavelength Zone. So there is a sign-up form. Please request access to Wavelength Zone by submitting that request. And we also have collateral white papers resources on the public page for AWS Wavelength. Thank you. And with that, I will hand it over to Saad to talk about some of the integration we have done with Aviatrix.
Thanks, Avi, for the Wavelength introduction. This is Saad Mirza with Aviatrix. And I'm going to talk about how Aviatrix is integrated with the Wavelength with some use cases. I will be also covering the AWS Gateway Load Balancer and its use cases. So with that, let's first talk about some of the use cases and how Aviatrix customers are actually taking advantage of Aviatrix and the Wavelength integration. So what I was talking about, I was just giving you an example from the online video games perspective. So here, towards the right-hand side of this slide, you see the video games are in two different tiers. And then these tiers need to communicate with each other, how we are providing that kind of communication. It's exactly the same architecture, centralized architecture, which our customers are already seeing this thing in their home regions as well. So same transit architecture basically means the Aviatrix spokes and Aviatrix transits over there. So now these applications, these games wants to make sure that there is definitely the inspection going on properly. Then there is the encryption is there. So everything is provided through the Aviatrix architecture. So all the routes, automatic routes management, the centralized management is pretty much the same way. Basically, the entirely everything is simplified deployment. Customers are also getting the benefits of the enterprise-grade visibility and troubleshooting also. All right, so can we go to the next slide? All right, so my next use case is about the virtual reality-based live sports. Because of the COVID, the sports fans who wants to go out to the stadium and watch the games live, they cannot do it right now, right? So they are looking towards the virtual reality-based companies, and what they are doing, they are taking the feed and then they are converting into the 3D videos and transmitting it back over to their subscribers. Subscribers are now watching the game, so they are happy. So they are getting similar kind of environment now. So just think from the VR reality-based companies' perspective. They are not entertaining only one type of sports subscribers. They have many channels, and then those channels have the same component which needs to communicate with each other, maybe some kind of analytics, something else. So what we are talking about, the transit architecture again over here, and the transit architecture along with the double security over here. So whenever these components are communicating with each other, which are sitting in the VPCs, they are going through the next generation firewalls and then getting to the destination. So all the benefits which I discussed previously, which are available in their home regions, are available to all of these customers who are utilizing the Aviatrix architecture in wavelength zone as well. So basically, no hairpinning if you have some components or maybe some tiers of the application sitting in the AWS home region, then the latency is not going to be to factor over here. Can you move on to the next slide? All right, this is a really good use case over here. So this use case is about the video analytics. What we are saying, we are giving you an example from the perspective of the rental car companies. From a user perspective, like me and you, when we are returning our cars, we are not going to see any difference. But from the rental car company's perspective, it's going to be really agile. So what is going to happen? When we are going to return the car, then at the gate, what's going to happen? These video cameras, they are going to take the 360-degree pictures. They are going to upload this thing into the wavelength zone. And then wavelength zone, there are analytics application who is going to provide the analytics. And by the time we get to the kiosk, the entire report will be available for the person who is holding the handheld, right? On his handheld, he will see, okay, by the way, this car has been through any kind of accident, or maybe there are new dings or anything like that. So this is really cool and very agile from the rental car company's perspective. So I only talk about only 3 use cases, but there are a lot more. Savi mentioned a lot of other use cases like connected cars, self-driven cars. So if you have any of those use cases, then please reach out to us. We'll talk about that in one-on-one meetings as well. Now, I wanted to talk about the, Nicholas, next slide, please. The Gateway Load Balancer and the Aviatrix. All right, so Gateway Load Balancer, this is a service that AWS recently announced back in the November of 2020. So what this the Gateway Load Balancer is, this is basically a load balancer for the third-party security virtual appliances. The deployment is simple. It's just a bump in the wire. And then you can actually take advantages like auto scaling the virtual appliances, when there is a lot of traffic going on, or maybe some other parameters, you can scale it up and scale it down both using that. Another good advantage of using this is in a centralized manner. You can use all your security appliances in a centralized VPC and then have all the spoke VPCs traffic inspected through this thing. So one important thing which the customers needs to make sure, the vendor which they are picking for utilizing this gateway load balancer must support the Geneve protocol. Not all vendors currently support it. Aviatrix already supports this thing. It's already part of our architecture. Now let's talk about how Aviatrix integrates with the gateway load balancer. Next slide. So before even talking about the gateway load balancer and Aviatrix integration, so let me just cover the fact that how Aviatrix customers prior to the gateway load balancers are utilizing the Aviatrix transit firenet, because the requirement of having the traffic inspected in an efficient manner is not new, right? So this architecture, which I'm showing you at the left of this screen, is the Aviatrix transit firenet architecture. So customer requirements are, I really wanted to have the full throughput, whatever my firewalls can provide. If firewall can provide 10 gigs of throughput, then you should be able to provide that. The architecture should not impose any kind of limitation, which is going to limit my day-to-day work. For example, I wanted to see the source IP. So it means I don't want source NAT anywhere configured. I wanted to keep this thing as simple as possible. So basically, I don't want BGP in there. And of course, no IPsec connectivity over here. Why? Because it's going to reduce my throughput. At the same time, the customer says, hey, the architecture should provide the end-to-end encryption for me. By the way, the segmentation is an added benefit because I wanted to make sure when my on-prem environment is communicating with my cloud environment, they are all segmented. So in this diagram, what we are showing that the green on-prem can communicate with the green spoke number 2 natively. But if they wanted to communicate with each other, for example, the green wants to communicate with the purple one, then all they need is a connection policy. So basically, the control is in customer's hand right now. So if they wanted to inspect spoke 1 and spoke 2 traffic, then they can configure the policy like that. When they don't want spoke 1 to communicate with spoke 2, they have that control as well, utilizing the policy-based architecture. So the customers who wants the repeatable architecture in a single region, in multiple region and multiple clouds, they go with this architecture along with some other requirements. For example, if you have the requirement like overlapping IPs, you wanted to make sure that you have the enterprise grade monitoring and troubleshooting, allowance monitoring, and all those kind of important functionality, then they tends to go with this thing. Now, let's talk about the AWS Gateway Load Balancer integration with the Aviatrix. So this architecture, you can see the architecture is exactly the same. The only thing which we are adding over here is the support of the gateway load balancers and then the NAT gateway over here for egress traffic. So all the benefits that I talked about in the Aviatrix Transit FireNet, you are going to get those benefits along with the scaling of next generation firewall. All right, so one more click. Another architecture which Aviatrix supports, and by the way, these are not the only 3 architecture which Aviatrix supports, but I'm showing you only 3 at this point, is with the AWS TGW. So that architecture is also supported. Now the question comes down to, hey, by the way, that all looks great, but I'm confused. Which architecture am I going to pick? So if you are AWS only customer and you have a requirement like, I wanted to repeat this architecture in the same region. Also, I'm looking for a high performance encryption. I do have a requirement of overlapping IPs and then troubleshooting tools and advanced monitoring along with the allowance monitoring. Then you go with the gateway load balancer design pattern number 1, which is the middle architecture. And we are seeing a lot of growth in this type of architecture. A lot of customers are adopting this. And if you are a customer who is a multi-cloud customer with the same kind of requirements, you tend to go with the architecture on the far left, which is the Aviatrix Transit FireNet. And the reason is very simple, because you cannot have the AWS Gateway Load Balancer in any other cloud than AWS. So basically, that's all I have with the Gateway Load Balancer as well. So next slide, and back to Rod.
Great. Well, thank you very much, everyone. I thought that was a really good presentation. We've got a poll that we always ask during the webinars. We really request that you answer the questions here. It gives us a lot of good feedback. And then I just want to highlight, if you have any questions, reach out to us at info@aviatrix.com, and we can get back to you with the right solution architects or experts that can answer your questions. You can also find lots of information about our product on docs@aviatrix.com. I also want to highlight our Aviatrix ACE program. If you're interested in getting more information and training, we've actually now reached, I believe, very close to 10,000 ACEs over the last year. So a very popular program. Next slide. And then I just want to highlight a couple other webinars that are coming up. On January 26th, we're going to be focusing on network security and compliance and some of the advanced capabilities that the Aviatrix product delivers in that area. And then on February 2nd, a real exciting webinar that we're going to be having with our new field CTO, who is a former Citibank Director of Global Network Engineering. So some really good insights that he has about large enterprises and the need for Aviatrix. So with that, I want to thank everybody for being on the webinar today. Hope you enjoyed it, and please reach out to us if you have any questions.